The Feynman Sprinkler problem is the question of what happens when you take a sprinkler that spins under its own force and reverse the direction of the pressure differential, meaning it is now submerged in water and sucking water in instead of spraying it out. The question focuses specifically on what the resultant rotation will be for the sprinkler. At least at the time of making this video, looking this up on Wikipedia will give you the answer that the sprinkler will not turn. Today, I'll present my own analysis, looking at this problem from the perspective of Newton's laws of motion, as well as briefly touching on why I believe the official answer may not be correct. Let us start by taking a look at our theoretical test setup for today. Our point of reference is going to be the ground. We are going to be assuming that the entirety of the container is securely attached to the ground. Next, we have water on the inside of the container. Inside that water, we can see the actual inverse sprinkler setup. It has two separate pipes in order to minimize center vortices, and it is attached to the bottom of the container via a bearing to allow for free rotation. As we start the test, I shall remind you of Newton's first law of motion. A body remains at rest or in motion at a constant speed in a straight line, except insofar as it is acted upon by a force. In our test, we shall begin with a static system, no movement in the water, and our sprinkler closed, filled with water, and at the same internal pressure as the container. Now, let us open the sprinkler and let the water begin to drain through the sprinkler. We now note that the water in the system is moving. This means that a force must have acted upon it. This force is gravity. However, we now have a problem. Gravity, in our scenario, is a force only capable of accelerating bodies in one direction, down. But let's take a look at all the water in the system, specifically in the arms of the sprinkler. We can clearly see that it is moving in a direction other than down. According to Newton's first law of motion, this means that another force must have acted upon it. In this case, a pressure differential. Now, let us look at Newton's third law of motion. For every action, there is an equal and opposite reaction. This means that just as for our water to move down, the planet creating the gravitational pull that moves it down must move up. For our water to move right, some object that creates the force to move it right must move left. In this case, it seems obvious to me that there is no object other than the sprinkler that could reasonably create this force. In this case, the sprinkler creates the sideways force by closing off the top and opening the side, thereby converting the vertical pressure differential created by gravity into a horizontal pressure differential. First, sucking the water towards the center of the sprinkler, meaning the equal and opposite force upon the sprinkler is created by the pressure in the water being lower here than here, meaning the arms are pulled away from each other. These forces being on the same line are balanced, meaning they are absorbed by the structural integrity of the sprinkler. However, at the next bend, we can see that the forces created by the pressure differential, though still in opposite directions, no longer lie on the same line. Instead, they lie on parallel lines, making them a couple, and meaning they will cause the sprinkler to rotate. At this stage, I believe it is important to touch on the official answer you can currently find on Wikipedia. I won't read the whole thing now, but here it is if you wish to pause and do so. The important part is that it states that any acceleration created by the water moving down the pipes is cancelled by the deceleration as the water hits the back of the pipes. At first, this may seem to make sense. However, it overlooks something very important. Acceleration followed by equal deceleration does still result in movement overall. Mass has still gone from A to B. Movement has occurred, and therefore some equal and opposite movement must also have occurred. In addition to looking at the exact forces acting upon each section of pipe and each area of water, we can also simply look at the bigger picture. To do so, we shall divide our entire theoretical world into three parts. 1. Our point of reference. This is the planet we are on and the container attached to it. 2. The inverse sprinkler. 3. The water. If we look at the net rotation of the water while it is draining through the sprinkler, we will see that while the water outside of the sprinkler is all simply moving towards the two openings at even rates from all directions, the water inside the pipes is rotating clearly in a counterclockwise direction. This means that the net rotation for the water is constant counterclockwise rotation maintained steadily against drag, friction, or any other slowing force. As we only have 3 parts in our world, and one of them is in a state of constant maintained counterclockwise rotation, according to equal and opposite reactions, some other part of our world must be rotating clockwise. Having heard everything I've said so far, I'll leave it to you to decide whether it makes more sense for the planet or the sprinkler to be rotating.